everyone, and welcome back to my online teaching platform. We are still on application of differentiation in relation to finding equation of a tangent to the curve and equation of a normal to the same curve. This is our fourth question, so we would like to find a solution to this given problem. Given that the function y is equal to a bracket of x minus 2 multiplying another bracket of 2x squared minus 3x minus 5. Find the equations of the tangent to the curve where it cuts the x-axis. Alright, so we are to find not just an equation of a tangent, but we are to find equations of tangents. So it means the tangents are 2 or 3. Alright, okay, so that's what we are supposed to do. Now, when you have a cubic function, this is a cubic function because when you expand a bracket, you are going to get x with an exponent of 3, and that makes it a cubic function. All right. Now, for us to determine a given equation of a tangent or of a given tangent, we need the gradient of the tangent and one of the point on the tangent. All right. So if the tangents are at where the graph cut the x-axis or where the curve cut the x-axis, then we need to find the point where the graph or the curve cuts the x-axis. Okay, so anytime you have a graph or a curve cutting the x-axis, it implies that at that particular point the x component is equal to 0, right? So let us illustrate it here. So I have my solution here. So if I have my x and y axis, if I have a curve in this form, see, these are the points where the curve cut the x-axis. So I'll name here to be point A, point B, and that of point what? C. So what the question is saying that, so what the question is saying is that we should find the equation of the tangent at this point. So it means each point has a tangent, all right? Each point has a tangent to the curve. So yeah, there will be a tangent over here. There will be another tangent here. Okay, it's not drawn to scale, so then there will be another tangent over here. So we are to find the equation of this tangent, all right, at this particular point. But you don't know the coordinate of this point. So what do we do? Since we know that at those points or at this particular point, the y component is always equal to 0, then it means we are going to make y equal to 0 so that we can get the values of x when y is equal to 0. All right. So we go for the function. The function is y is equal to 2, a bracket of x minus 2 multiplying a bracket of 2x squared minus 3x minus 5. All right. So this is the cubic function. And we would like to know the point where the curve cuts the x-axis. Okay. So what do we do? So it means we are going to find the x-intercept. So at x-intercept, y must be equal to 0. That is on the x-axis, y is equal to 0. All right. So we are going to plug in 0 for y. So it's going to be 0 is equal to a bracket of x minus 2 multiplying another bracket of 2x squared minus 3x minus 5. All right. So you can rewrite it as x minus 2 multiplying 2x squared minus 3x minus 5 all equal to 0, right? So these are factors of the cubic expression, all right? I'm dealing with only these parts. That's why I'm saying that it's an expression, right? Okay, only this part. I'm not including the equal to sign. So for you to solve for the x value, you have to equate each of the factors to 0. That is the right hand side of the equation. So we have x minus 2 must be equal to 0. Then we have another one, 2x squared minus 3x minus 5 also must be equal to what? 0. All right. So let us take the linear factor first. All right. So the linear factor is x minus 2. So we equate it to 0. Then we now have a linear equation, which is x minus 2 is equal to 0. Then we solve for x. So we are going to transpose the negative 2 to the right hand side, which becomes positive 2. So this is one of the values of x. Then we continue with the next component of the equation, which is 2x squared minus 3x minus 5 equal to 0. So this is a quadratic equation. So we need to solve for the values of x. So we need to find our AC, all right? Meaning the product of A and C. And A is always the coefficient of x squared. So the coefficient of x squared is 2 times the constant term, which is negative 5, all right? And this will give us a result of negative 10. So we need to find two factors of negative 10. That when you multiply, you get back to the negative 10. But when you add, you must get this value. You must get negative 3, all right? So let us look at those factors. Okay, let us look at those factors. And I think we are going to get negative 5 against positive 2. So it's going to be negative 5 and positive 2. Negative 5 plus 2 will give us negative 3, which is the same as this one. Then negative 5 times positive 2 will give us negative 10, which is also the same as this one. All right. So let us continue. So we are going to get 2x squared. Then we are going to replace the negative 3x with negative 5x and positive 2x. Then minus our 5 equal to 0. Right. We now have 4 terms at the left hand side. So we are going to factorize by grouping. So going to be 2x squared minus 5x in one bracket, then plus 2x minus 5 also in another bracket. All right. So we identify the highest common factor of each of the bracket. So the highest common factor of the first bracket is x, meaning you are going to divide through by x. So that will give us 2x minus 5. All right. Then let's look at the next one. The highest common factor of the second bracket is positive 1. So you divide each of the terms by 1. We are going to get 2x minus 5 all equal to 0. So you bring the factors together in one bracket, then you repeat one of the equal brackets. So we have x plus 1 multiplying 2x minus 5 all equal to 0. So we pick each of them and equate it to 0. So we pick the first factor, which is x plus 1, and equate it to 0. We solve for x. This implies that x is equal to negative 1. Then you pick the other factor too. So 2x minus 5 also equal to 0. So this will give us 2x. We transpose the negative 5. We are going to get positive 5 at the right hand side. We divide through by 2 since we are looking for the value of x. So this implies that x is equal to 5 out of, or 5 divided by 2. All right. So we know our x value, one of the x value to be the first one, x is equal to 2. We have 1, x is equal to negative 1. The another one, x is equal to 5 out of 2. All right. But we should know that these are the values of x for which y is equal to 0. All right. So we can put them in ordered form. All right. So, or in pairs. So it's going to be, one of the points is 2, 0, negative 1, 0, then, and 5 out of 2 against 0. So these are the points at where the curve cuts the x-axis. All right. Now we have to find the equations of the tangent at that particular point. So this is what we are going to do. Now we have the point where the tangents touch the curve. So it means these points are also on the three tangents. Okay, these are the points on the three tangent. So 2, 0 is on one of the tangents. Negative 1, 0 is also on one of the tangent, and 5 divided by 2, 0 is also on the last tangent. Okay. Now let us find the gradient of the tangent. So we know that at where the tangent touches a curve, the tangent that touches the curve must have the same gradient as that of the curve at where it touches the curve. So we start by finding the gradient function. All right. So this is what we are going to do. We find our dy dx. Let us find the gradient of each of the tangent. So gradient. We are now finding the gradient. So our gradient is dy dx. But we don't know what our dy dx is. So we need to differentiate the function. So y is equal to x minus 2 multiplying 2x squared minus 3x minus 5. All right. So this is what we'll be doing. We can expand through before we differentiate, or we use the product rule. But let us expand first before we differentiate. Okay, so I'm picking the first term here. So I'll use x here to multiply all the terms in the second bracket. When I'm done, I'll now go for the second term in the first bracket, which is negative 2. Also to multiply all the terms in the second bracket, 2x squared minus 3x minus 5. All right. So I'll be having y is equal to x times 2x squared will give us 2x cubed. Then x times negative 3x will give us negative 3x squared. Then x times negative 5 will give us negative 5x. Then we now continue with the next one, which is negative 2 multiply each of the terms here. Okay. So we have negative 2 times positive 2x squared will give us negative 4x squared. Negative 2 times negative 3x will give us positive 6x. Then negative 2 times negative 5 will give us positive 10. All right, so we need to group like terms. All right, so we have only a term with x cubed, so 2x cubed. Then we have negative 3x squared. Then you also have negative 4x squared, so it's going to be negative 7x squared. Then let us identify the terms with the x, just x. So we have negative 5x plus 6x. All right. So this will give us a result of negative 5 plus positive 6, give us 1. So plus x, then plus 10. All right. So this is what we are going to differentiate. Okay. So our dy dx, we differentiate the function. So we get 6 x squared minus 14x plus 1. All right. So this is our gradient function. So we need to now find the gradient at each point. Okay, the gradient at each point. So, we find gradient at the first point. We had 2 against 0. So at 2, 0. All right. So this is what we are going to. This is the gradient. This is our gradient function. So we only have x component. So our dy dx will be equal to 6 times wherever you see x, you put 2 over there, because that's the x component in this point is 2. So 6 times 2 exponent 2 minus 14 times 2 plus 1. So you have 2 exponent 2 is 4 times 6 will give us 24. Now negative 14 times 2 give us 28 plus 1. Right. So we have 24 minus 28 to give us negative 4 plus 1 give us negative 3. Right. So the gradient here is negative 3. All right. So we can now find the equation of one of the tangents since we know the gradient of that particular tangent. So using the formula y minus y1 will be equal to the gradient m multiply x minus x1. All right. So here our gradient is 3 for this particular point. Our gradient will be 3, but let us get our y1. So the point is having a coordinate of 2 and 0. So it means our y is 0. So y minus 0, our y1 is 0. Then the gradient is negative 3. Our x is 2. So we replace the x1 with 2. So we have y is equal to negative 3x plus 6. Okay. Then you are going to get a result of y plus 3x minus 6 equal to 0. So this is the equation of one of the tangents. So we now go for the second point. All right. We have one of the points to be x is equal to negative 1. Sorry, one of the x value to be x is equal to negative 1. So we go for that point. So at 1, negative 1, negative 1, 0, you need to find a gradient. So our dy dx, you know our dy dx to be 6x squared minus 14 plus 1. 6x squared minus 14x plus 1. So you just plug in 1. So 6 multiply negative 1 squared minus 14 also multiply negative 1 plus 1. Right. So negative 1 squared times 6 will give us 6. Negative 1 times negative 14 will give us positive 14 plus 1. And this will give us a result of 21. All right. So the gradient at the point with coordinate negative 1 and 0 is 21. So we find the equation y. So y minus y1 is equal to the gradient at that point, then x minus x1. All right. So we know our y1 to be 0 because at that point y is equal to 0, equal to the gradient multiplying x minus the x coordinate of the point. And the x coordinate of the point is negative 1. All right. So we are going to get y is equal to 21 multiply x plus 1. Because negative times negative gives us positive. So this becomes y is equal to 21x plus 21. Here is the same as y minus 21x minus 21 equal to 0. All right. So this becomes the equation of the tangent at the point with coordinate -1 and what? 0. All right. So this becomes one of the equation of the tangent. Okay. Then we look at the next one. That is at the last point. Let's go through it and pick that particular point. Okay. So it's like with this particular one. 5 divided by 2 against 0. So let's find the gradient at that point too, so that we can use it to find the equation of the tangent at that point. So at 5 divided by 2 comma 0, let's just find the gradient over there. So we know our gradient function to be 6x squared minus 14x plus 1. All right. So we are going to find the gradient over. It's going to be 6 multiplying 5 divided by 2 squared minus 14 also multiplying 5 divided by 2, then plus 1. So 5 divided by 2 squared will give us 25 divided by 4. You square each of them. Then here we are going to multiply 14 by 5 out of 2 by 2 divides itself 1. 2 divides 14. We are going to get a result to be 7. But there's negative over here. So -7 times the 5 over here. We are going to get it to be -35, right? Then plus 1. Here 2 divides itself, 4 divides 2, you get a result of 2. Sorry. 2 divides 4, you get a result of 2. And 2 divides 6, you get a result of 3. All right. So you'll be getting 3 times 25, and that will give us 75 divided by 2, then minus 35 plus 1. So 35 plus 4, -35 plus 1 will give us -34. All right. So at the end, we are going to get a result of, let us find the LCM. So we get 75. Okay, then you just multiply this one by 2. The LCM is 2 over here, right? Because -37, so -34 is the same as -34 over 1. So I can introduce 1 here. So the LCM becomes 2. So here will be 75 minus 68. All right. And this will give us a result of 7. 7 out of 2. Okay. You can equally use your calculator to verify. So if you want to check whether you are, so you can use your calculator to verify, so that you'll be very, very sure. Then minus, so I'm using a calculator to verify, so that I'll be very sure. Okay, then plus 1. So yes, the calculator gives an answer of 7 out of 2. Okay. So the answer is 7 out of 2. So this is a gradient at this point. So let us find the equation at the point where the tangent touches the curve. So we have the equation of the tangent y minus y1 equal to the gradient at that point multiplying x minus x1. And you know your x1 to be the x component of the point and y1 to be the y component. So our point is 5 divided by 2 against 0. So y is still 0 because we are dealing with the x-axis. So y minus 0 will be equal to the gradient here, which is 7 divided by 2 multiplying x minus 5 divided by 2. All right. Then we now expand the bracket. So here you write it as y is equal to 7 divided by 2 multiply x minus what? 5 divided by 2. All right. So we can get our LCM here to be 2. So it means we are going to multiply through by 2 to get 2 times y is equal to 2 times 7 out of 2 multiply x minus 5 divided by 2. All right. So this cancels this. We have 2y is equal to 7 multiplying x minus 5 divided by 2. All right. So we'll be having, so we can now multiply again. We are going to get 2y is equal to 7x. Then the 7 also multiply the negative 5 divided by 2, get negative 35 divided by 2. So we still need to find the LCM, which is 2. So we are going to multiply through by 2 again. So then 2 times 7x, then 35 divided by 2 also times 2. So here gives us 4y equal to 14x minus 30 what? 5. All right. So the equation here becomes 4y minus 14x plus 35 equal to 0. So this is the third equation. So this is our third equation. All right. Okay. So anytime you have a question in this form, you have to pay attention to the condition given. We have to find the equations of the tangent to the curve where it cuts the x-axis, okay, to the curve where it cuts the x-axis. So it implies that the tangent to the curve is at where the curve cuts the x-axis. So anytime a curve cuts the x-axis, it implies that the y component of that particular point is 0. Okay, so how do we get those points? By substituting 0 for y in the given function. Since at x-intercept y is equal to 0, then you solve for the x values for which y is equal to 0. Okay, then you get your point. When you are done with those points, you use those points to get your gradient at the point that you have obtained. So we know our gradient function to be dy dx. So the dy dx is a gradient function at any point on the given curve. But if you want to find the gradient at a particular point, then you need to substitute the coordinate of that point into the gradient function so that you'll be able to get the gradient at that given point. So since we are looking for the gradient at the point where the curve cuts the x-axis, after you have obtained those values of x, and you have paired them with their corresponding y values. So you will say the y values are all 0. You will now plug in each of the x components into the gradient function to get their corresponding gradient. Okay, then you use the point and its corresponding gradient to find the equation of the tangent at that particular point. All right, so we'll be